This is the screencast for section 3.6, example 2. We're skipping over example 1. I don't really like it. We are going to do its now try problem though. Alright, so we've got the chain rule that we're going to learn in section 3.6. If you are taking the derivative of a composite function or a composition function, you have to use what is called the chain rule. The chain rule in math lingo here is when you have a composition function, you take the derivative of the outside function of the composition, leave the inside alone, and then multiply by the derivative of just the inside. Now, basically, you start on the outside and work your way in. So let's look at an example. The polynomial, this guy, also equals 3x squared plus 1 squared, so a binomial squared. They want us to find the derivative of this. Well, I know what you're saying. Ms. Larson, I can just take the derivative of this polynomial. Okay, so let's do that. Y prime equals, let's see, 36x cubed plus 12x and then plus 0. So now we know what our answer is going to be, but now let's practice the chain rule. Off to the side here, I'm going to show you how the chain rule works. Our original function now we're going to write as this composition function. Y equals u squared. They've identified u as 3x squared plus 1, the inside of this composition function. So when you take the derivative, you're going to have y prime equals 2u and then times the derivative of u prime. So let's see how that translates to the actual function. Y equals 3x squared plus 1 squared. So y prime is going to equal 2 times 3x squared plus 1, now to the first power, times the derivative of the inside, so the derivative of 3x squared plus 1, which is just 6x. So if we multiply that out, we get the same thing that we got when we did it as a power rule. Now I know, why would you do all these steps if you can just do the power rule in one step? Well, you are going to see now in the two now try problems situations where you only can use the chain rule. You have no other options. So now try problem number 1 says use the given substitution and the chain rule, so they're giving you a clue, to find dy dx. They also told you what the inside function of this composition is. The inside is 3x plus 1, the outside is the sine of x. So off to the side, how this will work, we have y equals the sine of u. So now to take the derivative of y, dy dx, which is what the problem is asking for, is going to equal, okay, the derivative of sine is cosine of u times the derivative of u, so du dx. So now let's see how that translates to the actual function. Y equals the sine of 3x plus 1 is what we're starting out with, this composition function. Dy dx then is going to equal, the derivative of sine is cosine of just 3x plus 1, and then times the derivative of the inside, so just 3. So I get 3 cosine of 3x plus 1, and of course you should graph to check that on your calculator and make sure you are right. The now try problem number 5 says use the given substitution, so they gave this to you. By the way, that is just a stepping stone. In the future, they will not be giving you the inside function at all. But use the given substitution and the chain rule to find dy dx. Okay, this one's going to be a little bit messier because I've got this quotient rule. Yuck. Alright, in simple terms, we have y equals u squared. So to find dy dx, that's going to be 2 times the function u, now to the first power, but then times du dx, and this is going to be the big mess. Well, let's give it a try. Y equals this quotient squared. So dy dx is going to equal 2 times that quotient, but the quotient, nothing happens to that because it's the inside function. Nothing happens to it yet. Now to the first power. And then we need to multiply by the derivative of this quotient. So I need to use quotient rule. And then here's my result of the quotient rule. So we took the derivative of just the square part of this composition function, the outside piece of the composition, leaving the inside alone, and then multiplied by the derivative of the inside. So let's simplify and see how that works out. And I get 2 sine of x all over 1 plus cosine of x quantity squared.